Hi everyone, today I'm going to teach you lesson 13-2 on graphing square root, cube root, and cubic functions. Before you begin warm-up number 1, I want to just point out a couple of things to you. You will be graphing two functions. You're going to graph the function f of x equals the square root of x, and you're going to be graphing g of x, which is equal to negative square root of x plus 3 plus 1. So I just want to show you really quickly how to put in g of x into your y equals, just to help you make a little bit more sense of how to use the calculator to do this. So we're going to go into our calculator, and we're going to go into y equals. What you're going to do is we're going to start with a negative, and then to get our square root sign, we're going to hit shift or second x squared. Now what's underneath the radical is just the x plus 3. We're going to type x plus 3, and then it's really important that you hit the side arrow to get out from underneath the radical sign so that you just have plus 1 on the outside. Okay? So let's try out this question where we graph both of these functions and then explain how the graph has changed from f of x to g of x. So pause the video and give that one a try. Okay, so let's try this question out. I'm going to first graph f of x equals the square root of x. So the first thing I'm going to do is I'm going to go into my calculator and I'm going to put in my y equals the square root of x, and I'm going to copy down a table of values that has easily readable points. Okay, so you've got x and f of x. If you take a look on your calculator, it says there's an error for all of the outputs that are negative values. That actually should make sense because we can't take the square root of a negative x value. It's what gives us an imaginary number, which you'll learn about in Algebra 2. So first of all, let's copy this down. We've got 0, 0, 1, 1, 4, 2, and 9, 3. We can obtain these values just by putting the square root of x into our y equals and checking out the table. These values should also make sense because our input is the x value and the output should be its square root. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So we're going to plot these points. We've got 0, 0, 1, 1, 4, 2, and 9, 3. We're going to connect it with a curved line and label it as f of x since we have two functions on our graph. So this is what our cube root function will look like. It's going to have a slight curve to it, and it's going to be moving towards the right side of the graph. Okay. Let's take a look at g of x equals the negative square root of x plus 3 plus 1. So I'm just going to show you this in the calculator. Okay, so we have it in our y equals. I showed you how to set that up, being really careful to only have the x plus 3 under the radical sign and the plus 1 on the outside. So what I personally like to do is I like to check out the graph. I want to know what it's going to look like before I graph it so that I know I'm going to be, when I plot my points, if I'm doing it correctly. So now I'm going to look at the table. So I'm going to notice that my x values on the top are producing error points for -6, -5, -4. So I'm not going to use those. I want to choose points that have easily readable points or have integer outputs. So I'm going to use -3, 1, -2, 0, and anything else that's easily readable on my graph. Okay, so I'm going to go back to my notes and I'm going to copy down a table for g of x. I've got x and g of x. Okay, so the first easily readable point that I see there is -3, 1. The next point I have is -2, 0. We've got 1, -1, and 6, -2. Okay, so now I'm going to plot those points on my graph. 1, -2, 0, 1, -1, and then 6, -2. Okay, I'm going to connect these points. With my curved line of my arrow, and I'm going to label it g of x. Okay, so the next question asks me, explain how the graph of g of x has changed from its related graph f of x. So I'm going to look at f of x and see what's happening to get to g of x. So the first thing I notice is that the curve is opening up in the opposite direction. So if you take a look at your x-axis, it's kind of like mirrored along the x-axis. So when we have something that is being mirrored over one of the axes, it's a reflection. So the first thing that happened is it's reflected over the x-axis. The next thing I noticed is that the starting point is in a different spot. So I want to say, if I was going to reflect 0, 0 over the x-axis, it would stay in the same place. So now, because it's in the same place, I'm going to use that point to help me figure out the shift. So it has also been shifted to the left 3 and up 1. Shifted left 3 units and shifted up 1 unit. And that should make sense to you also just by looking at the equation. So the first thing is that negative sign is a reflection. The +3 under the radical talks about the left and right shift. And then the +1 talks about your vertical shifts, or up, down. All right, so for warm-up number 2, I'm just going to show you what to do to get the cubed root in your calculator, just to help you get started. So when you want to find the cubed root of something on your calculator, the button commands are going to be math, and then you're going to hit the number 4. I'm going to show you why that happens. So let's go to our calculator. I'm going to want to see what that graph looks like, so I'm going to go into my y equals to get started. So on your left side of your calculator, so where the y equals are, you're going to go down a couple of keys and hit math. If you take a look at option number 4, it has a cubed root sign. So that's why we hit math and then we hit 4 to get the cubed root. So for this question, we're going to be doing the cubed root of x minus 2. Okay, so that's how you get started for that question. So take a moment to pause the video and see if you're able to graph this function on the specific domain between -6 and 10. Okay, so I'm going to show you how to do this. So I'm going to go back to my calculator and I'm going to take a look at the graph. So the graph of this cubic function, of the cube root. So the graph of this cube root function has this certain shape to it. So what I'm going to do is I'm going to take a look at the table, and again I'm going to copy down easily readable points, but more specifically I'm going to look at points in the specific domain that they give me. So because they specifically say that x is between -6 and 10, I'm only going to use the values that are between -6 and 10 that are easily readable. So you take a look at your outputs, you only want to use the points that are easily readable. So I'm going to copy down this information onto my notes. We've got x and y. So the first easily readable point I have is -6, -2. The next easily readable point is 1, -1. And then we have 2, 0, 3, 1, and 10, 2. So I'm just going to copy those down, plot those points. Okay. 1, 2, 0, and 10, 2. Okay. So now I'm just going to connect these points, and I want the graph to look similarly shaped as it does on my calculator graph. So it's going to have that cube root curve to it. And I am not going to include arrows. The reason I'm not including arrows is because they give me this specific domain that they only want the x values between and including -6 and 10. So we're going to have closed circles at the end and no arrows. So that is the graph of a cube root function. The last one we're going to look at, warm-up number 3, it says which equation represents the graph below. So I'm going to give you a moment. I want you to pause the video and see what you can do to get these answers. Okay, so the first thing you want to do is I would advise that you first start by looking at the roots of your graph. So we've got 3 roots this time. And my roots are at x equals -2, x equals 1, and x equals 3. Now, if you take a look at the options that they provide to you, they are listed in factored form. We're not given the roots. We could find the roots, but we want to do what's going to be most efficient for us. So I kind of want to work backwards from my roots and get my factors. So it's kind of like working backwards, similar to our quadratic unit where we're either given our factors and how to find our roots. We want to use our roots to find our factors. So our factors, we're going to y equals, are what came before that when the t-chart. So if x was equal to -2, the factor was x plus 2. They ended up to kind of be the opposite sign. So then we have x equals 1, which is x minus 1 would be the factor, and x equals 3, the factor there would be x minus 3. Okay, so this is an equation of our graph. It's not simplified, but it is in factored form. So if we were going to put this in the calculator, it would give us the graph that you see on the chart. So what I think is the easiest thing to do from here is you want to graph this in your calculator in y1. The next thing you want to do is put all of these choices into y2. Put each choice into y2 separately. What's going to happen is whichever one represents the graph will be graphed exactly on top of the highlighted function. So let me show you what I'm talking about. I'm going to go back to my calculator. I'm going to exit out of here, and I'm going to go into y equals. So I'm in my y equals, and I want to put the highlighted function in y1. That's going to give me the graph that is already there. So we have x plus 2, x minus 1, and x minus 3. Okay, quickly just going to graph it to show you this is exactly the function that we have. So the quickest and most efficient way to do this is to take each choice that they give you, choice 1, 2, and 3, and I want you to put them separately into y2, one at a time. This way, whichever one graphs exactly on top of that y1 function is equivalent. So let's check out the first choice. We have x plus 2 times x squared minus 4x minus 12. So now that I have these two functions, I'm going to see if they are the same, they will be exactly on top of each other. It will look like one graph. If they are different, the two graphs will be in different locations. So let's take a look. All right, so I can already see that the blue graph, which is my starting graph, which is the one I have, is not the same as the red graph. They're not right on top of each other. So choice 1 is already going to be out of the question. So I'm already going to put an X on choice 1. Can't be choice 1. I'm going to try the same thing now for choice number 2. I'm going to go into Y1 and I'm going to clear out my Y2 and put in choice 2. So that's X minus 3. And then we have X squared plus X minus 2. Okay, graph it. You're going to see this only looks like we have one graph. In your calculator, each graph is graphed separately. You'll see the graph formed for the first one, and then you'll see the graph formed for the second one. In my graphing app, it only graphs it as it is. So it looks like there's one graph there, but there's actually two, and they're graphed right on top of each other. So choice 2 is equivalent. So we have choice 2 so far. Okay, so that only eliminates choice 1. So I have to, and choice 3. I have to check out if number 3 is going to be an exact match. Let's check it out. Okay, so back into Y equals, clear out Y2 again, and put in that last choice. We have X minus 1 minus 1 times X squared minus 5X minus 6. And we get two different graphs again. So we can eliminate choice number 3. And so our answer for that is choice 2. Another method you could have used to do this would be to factor out all of these and see which one gives you the same exact factors as you do here. It's up to you if you'd rather factor them out or use the calculator to help you. Okay, so let's get into the couple of questions for our lesson. Question number 1, which graph represents y equals square root of x minus 2? So, easiest thing to do is put into y equals to see which one looks exactly the same. So I'm going to do that right now. I'm going to clear these out. And I'm going to put the square root of x minus 2. I'm going to check out my graph. And that looks like choice number 4. All of the other graphs look completely different. So choice number 4. So you're going to notice that a square root function has a similar look to this function. It's either on the top of the x-axis or below the x-axis, but it always has that same shape. So that's the shape of a square root function. And that's the only one here that has that shape. For choices 1 and 3, we talked about those graphs in the past. These are quadratic functions, each of those. That would be like an x squared equation, and choice 2 is linear, where it's just like an x plus or minus a number. Okay, so our answer here is choice 4. Question number 2. A polynomial function contains the factors x, x minus 2, and x plus 5. Which graph or graphs could represent the graph of the function? So we're going to use these factors to find the roots of the function. So our polynomial function has the factors x, x minus 2, and x plus 5. I'm going to use a t-chart, so similar to our quadratic unit. If I want to find the roots, I'm going to set each factor equal to 0 and solve for x. We get x equals 0, x equals 2, and x equals -5. Remember, the relationship between a factor and its root is that they're kind of like opposite signs. So if the root has x minus 2, or the factor has x minus 2, the root's going to be the opposite, which is x equals 2. So our function has roots at x is 0, 2, and -5. So whichever graph has those three roots exactly is going to be what could represent this function. So I'm going to check which ones have roots at all 3 points. So graph number 1 is good so far. Graph number 2 only has 2 roots. So only has 2 roots, so that one can't be possible. Eliminates choice 2 and 4. And graph number 3 doesn't have the exact same roots. It has roots at +5, 0, and -2, which is not the same. So our answer here is choice 1 only. Okay, let's check out number 3. This is the shape of a cubic graph. That means it's going to be like an x cubed looking function. Which function could represent the graph of f of x? Okay, so again, we're going to use our roots to help us come up with an equation for this function. So my roots are where my graph crosses the x-axis. So that's going to be at x equals -4, x equals -2, and x equals 1. Okay, so similarly, we're going to create an equation and find its factors by working backwards. So if the root was -4, the factor is x plus 4. If the root's -2, it's x plus 2, and if the root is 1, it's x minus 1. All right, so now I'm going to use this. This is the equation of that graph in factored form, and I'm going to put it into y1. Similarly to one of the prior questions, we're going to put each of these choices into y2, and we're going to see which one maps exactly on top of it. Okay, so when I do that, I'll show you an example just for 2 options. I just want you to see what's going to happen. I go into y equals. We have our highlighted function, x plus 4 times x plus 2 times x minus 1. And I'm going to put the first choice in my y2 and see what happens. So then I have x minus 2 times x squared plus 3x minus 4. Okay, let's see what happens. Oh, it's x plus 2, that's right. X plus 2 times x squared plus 3x minus 4. I'm going to graph it, and you can see we only see one graph, which means that these 2 functions are the same function. So if I go back to my notes, choice 1 works. So choice 1 is actually the correct answer. I just want to go back and show you choice 2 so you can see what it looks like when it's not the right choice. Okay, so if you notice, the only change here is that it's an x minus 2. So I'm just going to change that to x minus 2. and you'll see the graph, it does not align exactly the same. So this is not the same function. Okay, the same thing's going to happen for choice 3 and 4. I just, in the interest of saving time, I'm not going to show you those. So the answer for this one is choice 1. All right, our last question for our guided practice. Question number 4. In the diagram below, f of x equals x cubed plus 2x squared is graphed. So that's the top function, that's f of x. Also graphed is g of x, which is on the bottom, which is the result of a translation of f of x. So a translation just means a slide. That means we're moving something either left, right, up, or down. Left, right, up, or down are the options we can have. All right, so I'm going to start out by looking at the roots for f of x. We have a root at 0, 0, and a root at -2, 0. If I take a look what happens, each root is just moving down by 4. So 0, 0 becomes -4, 0, and -2, 0 becomes -2, -4. So each point is shifted down 4 units. So if I want to come up with an equation for g of x, we can have g of x is the same function as f of x, except we're moving it down 4. So when we're talking about a downward shift, it's on the outside of those parentheses. And because it's down, we're going to be subtracting 4. So down 4 units. If we were shifting it left or right, we would put those shifts inside the parentheses, similar to our unit on functions. Okay, and it wants us to explain our reasoning. So the graph of g of x is shifted down 4 units. So your classwork for today will be to submit these class notes as well as the 2 practice pages on the following pages. So submit each one of these pages to your teacher. If you have any questions, feel free to use this video and rewind it as you need, or contact your teacher via email. I hope this video helps, and I hope you are all doing well. Have a great day.